In this video, we present an OSLC-based interaction scenario between a system design tool, SYSTEMDESK, and the requirement management tool DOORS. In the scenario, we link requirements from DOORS to model artifacts. We use OSLC for tool integration. We use the iOS meter model to represent the system architecture as OSLC resources. For requirements, we use the requirement management namespace already defined in OSLC. We use a rm_satisfies property that is already defined in OSLC to represent the link between requirements and model artifacts. Our scenario consists of 4 steps. As first step, we refine a requirement that already exists in DOORS. Next, we use SYSTEMDESK to add a new runnable entry to an existing component. Then we commit the model that we just modified to our AUTOSAR server. As the last step, we use the generic OSLC client to link the new runnable entry to the new requirement. This diagram shows the software architecture. On top we have SYSTEMDESK and DOORS. SYSTEMDESK's AUTOSAR export is used to pass the model to the AUTOSAR server that maps AUTOSAR to iOS and exposes the model via OSLC. The generic OSLC client can browse both the iOS resources and requirements and can create links between them. We use an abstract example to demonstrate the scenario. The system architecture consists of only one component that we call composition for simplicity, that contains 2 subcomponents, atomic software component 1 and 2. In DOORS we have 5 requirements that are numbered from 1 to 5 and not defined further. In the initial state, requirements 1 to 4, the components and the runnable entry for atomic software component 1 already exist, as well as the links between them. Requirement 5 and a runnable entry for atomic software component 2 are created during the scenario and therefore grayed out here. Let's start the demonstration. The first step is that the requirement engineer creates a new requirement in DOORS. This requirement shall refine an existing requirement. These are the requirements for our example system. For simplicity, they are just labeled requirement 1 to 4. First, we add a new requirement. Let's call it requirement 5. We save the changes. Requirement 5 shall refine requirement 3. We use a link set to represent refinement in DOORS. Here you can see all the refinement relations. We draw a new link from requirement 5 to requirement 3. We save all our changes and close the modules. Now we can start the second step. The design engineer uses SYSTEMDESK to add a new runnable entry to a component. At the left, you can see the component structure of our example system. We will add an internal behavior and a runnable entry to Atomic Software Component 2. Now we go to the third step. The design engineer exports the modified model as an AUTOSAR model. The design engineer commits the modified model to the AUTOSAR server. We save the model and export it as an AUTOSAR XML file. Now we come to the last step. The design engineer browses the model and the requirements using the generic OSLC client. The design engineer links the runnable entry to the requirement. To access requirements via OSLC, we have to authenticate to DOORS first. On the left, you can see all the requirements in DOORS. On the right, you can see the components and their subcomponents. You can see that requirement 5 refines requirement 3. We can define the satisfies relationship by simply dropping the runnable entry on the requirement. The requirement is automatically updated. Let's draw a conclusion. We use OSLC to integrate SYSTEMDESK and DOORS. There is a one-to-one mapping between AUTOSAR and iOS, so that we can use the iOS meta model to expose the system architecture from SYSTEMDESK via OSLC. For example, compositions and atomic components are mapped to iOS components, and runnable entries are mapped to iOS behaviors. To integrate DOORS, we use the native OSLC interface provided by DOORS. We use a link set in DOORS to represent refinement between requirements. We let DOORS populate the internal links from the set via a custom property in OSLC, so we can see the refinement with the OSLC client. The predefined satisfies property in OSLC requirements makes it possible to link iOS resources and requirements together.